Hey guys, my name is Javesh and I'd like to welcome you to this new YouTube series on the basics of cloud computing. We're going to talk about everything that you need to get started with the cloud in a 10 video series wherein each video will be from 10 to 15 minutes. These videos will be released at 6 p.m. Indian Standard Time, Monday to Friday. So do not forget to hit the subscribe button and the bell icon so that you can be notified whenever the video comes out. Now let's just quickly begin talking about the session plan followed by today's content, that is Introduction to Cloud Computing. The first video today is going to be on the introduction to cloud computing, followed by the next video which will be coming up tomorrow, which is going to be a comparison between a on-premise solution and a cloud solution provider. The third video is going to talk about the different cloud deployment models covering public cloud, private cloud, and the hybrid cloud. Fourth video is going to be on the cloud computing infrastructure, followed by the last video for the week that is going to be a comparison between major cloud computing platforms. So we're going to compare AWS, Azure, Oracle Cloud Infrastructure, and the other options available in the industry in terms of cloud. The sixth video starting next week is going to be on virtualization in cloud. We're also going to talk about hypervisor, that is virtualization done by a software. It's a very interesting concept. Seventh video is going to be on the security concepts related to cloud. The eighth one coming out next Wednesday is going to be the challenges of cloud computing. Ninth video is going to be talking about the scopes and the jobs in the field of cloud. The 10th video and the last one for the series is going to be on how can you start a career in cloud computing. We'll also be discussing about the certification options that are available in cloud and if you should pursue a certification for your business requirements. We'll be talking about introduction to cloud computing. I'll be also explaining what's the difference between an on-premise solution with an example, and we're going to compare that to cloud so that you can understand the concept better. After which we'll be discussing infrastructure as a service, platform as a service, function as a service, and software as a service. Cloud computing is the on-demand delivery of IT resources. Now you would ask me, what are these IT resources? These IT resources include compute servers, database servers, software, and analytics. The cloud deployments are faster and easy to scale. The time taken to set up the infrastructure is less and you can go up and running faster than going with the conventional on-premise solutions. The reason for this is that you do not need to go and purchase a physical hardware and then do all the setup, which is a time consuming process. You can just create your account on a cloud service provider such as AWS or Azure. You can then request the amount of services that you need, and within a couple of minutes your server would be up and running. The cloud is also scalable, which means you can scale up and scale down as per your initial business requirements. So let's say if you're getting high amount of traffic, you can automatically scale up, and if you are getting less amount of traffic, you can scale down. Hence it is also going to reduce your cost because you'll only be paying for the amount of services that you're using. The next and the best point about this is that you do not need any upfront investment with cloud because you're not buying the resources, you're just renting them out. So you can go with on the go pricing model, which makes it very good for a lot of startups and a lot of new companies which do not have a lot of initial investment to start their servers with cloud. In this slide, you can see two images on your screen. On the left hand side, you see a typical on-premise hosting environment. So I've added a few servers and a few database servers. So these are some basic requirements for any organization that you can think of. Any organization would be needing a compute service and they'll also be needing a database. Now what is happening in on-premises that you are actually catering to your own users. So let's say if I am running a company and I'm having around 100 employees and these 100 employees need to access an application on a daily basis. If I go with the conventional on-premise model, I will be taking care of the services on my own. I'll be taking care of my own databases, I'll be taking care of my own application servers and all the other resources along with them. I can also outsource someone else. Like let's say if my requirement is really high, I can go and outsource my services to a third party company such as TCS, Infosys, or some other big brand name. In this case, I have to take care of my maximum requirements. Let's say if my system is capable enough of handling 100 users, and at a particular amount of time, the average number of users that are accessing it is just close to around 50 to 60. The 30 to 40, the top limit that you see, right? Let's say anything above my average, the buffer space which I'm keeping is extra. So I am not utilizing my system to the best of its capabilities because I do not have any option to upscale or downscale in case of on-premise. There are some limited number of resources and I have to just stay and do whatever I can with these resources. If I expand my resources, the problem is going to be my resources are going to sit idle, and if I decrease my resources, the problem is going to be my users will not be able to get the same experience as they should be expecting. Whereas on the other end of the screen, you can see that I have tried to explain a cloud service model in which you can see various application servers and various database servers of different size put together. There are other resources as well, but just for simplicity, I am taking into consideration the compute and the database services. So let's say if multiple users have to use this, rather than one company having its own on-premise server, if they go and create an account with a cloud solution provider, which is having somewhere around 50 to 70,000 servers racked up in one location, the cost of operations is going to go significantly down. So what happens over here is I am using my same services. The output is going to be pretty much the same. The only difference is in the way I execute it. In the first example, everything is managed by me. I have full control over the hardware. In the second case, in case of cloud, I do not know where the hardware is. I'm just paying a subscription plan in order to get a virtual server and virtual memory, which is actually going to help me reduce my cost, give my customers higher availability, and scale up if the requirement goes high. IaaS or infrastructure as a service is one of the most basic category of cloud computing services. With IaaS, you rent the IT infrastructure including servers, virtual machines, storage, networks, operating systems, or even VPCs, that's a virtual private cloud, from a cloud service provider, and you get the option to pay as you go. If I tell you slightly more about IaaS, what actually is happening is you do not need to take care of the hardware, the power supply, and the network connectivity is taken care by the cloud service provider. You have to install your own operating system. You have to take care of the patches, of the antivirus, your own programming language, and the code, obviously. So it's all managed by you. In IaaS, the offerings by various cloud service providers are AWS has got its own EC2, that is Elastic Compute Cloud. Google has Google Compute Engine. Microsoft Azure has Azure Virtual Machines, also referred to as AVMs. And Oracle has OCI bare metal machines in this category. The next category is PaaS or Platform as a Service. Platform as a Service allows you to avoid the expenses and complexity of buying and managing software licenses, the underlying application infrastructure, middleware, or the development tools and other resources. So you as the developer will only have to take care of your code, and you'll have to have a container. You'll have to go to the service and tell the service which programming language and which version are you looking forward for. Apart from that, everything else is taken care by the cloud service provider on its own. So they basically handle the operating system and the bugs and fixes, whatever updates come in into the application, it's all handled by the cloud service provider. A few examples in this case can be AWS Elastic Beanstalk, Azure Web Apps, and Google App Engine. Function as a Service or FaaS is a category of cloud computing services that provides a platform allowing customers to develop, run, and manage application functionalities without the complexity of building and maintaining the infrastructure. This typically is associated with the deploying and launching of an application. If I explain this in detail, let's take example of AWS Lambda. What happens in this case is you can either write the code in one of these languages supported by Lambda on your laptop and deploy the code to the Lambda function, or you can start coding from the scratch in an inbuilt IDE which comes with the user interface or the web interface that you get with AWS. The advantage of using a serverless functionality such as AWS Lambda or FaaS is if you were going with server, you will be paying for the number of hours your server is running. But that's not the case with function as a service. In case of function as a service, your billing is going to be on the number of executions. So let's say if I am getting 100 executions in 1 year, I'll only be paying for the 100 executions. This brings down the cost significantly. Hence, this is the choice of a lot of people these days. A lot of new websites have started moving to the serverless model where they're creating static websites with dynamic APIs, and the APIs are built over function as a service. A few examples of some programming languages supported by uh, a service such as AWS Lambda can be Python, JavaScript, Java. So you can choose any of these languages, or you can also have Docker deployments which you can go and deploy. So it gives you a vast variety of options available, and the cost is significantly low. A few other examples apart from AWS are Azure Functions and Google Cloud Functions. SaaS, or Software as a Service, is a method for delivering software applications over the internet. With SaaS, cloud providers host and manage the software application. They also take care of the underlying infrastructure, handle any maintenance like software upgrades and security patches. Users connect to the application over the internet, usually with a browser on their phone, tablet, or PC. If I give you an example, any software that you're running using a web browser which does not require you to install something in your device is actually the case where the software is actually installed on the cloud and you're just getting a web interface and you're using it as a consumer. If I give you an example, you can think of any Google application which is running on the internet. Let's talk about Google Clouds, Google Sheets, or Google Slides. All these three come under the category of software as a service. Another good example can be Dropbox, Microsoft Office 365. And when I talk about Microsoft Office 365, I'm talking about the version which is available for you to access online on your web browser. Not talking about the one which requires you to install the Office on your own system. So this is pretty much it about software as a service. Since you have reached to the end of the video, I hope you liked the content. Please do like the video, share it with your friends, and hit the subscribe button. That supports us a lot. And we'll be coming up with a new topic tomorrow. Till then, have a great day.